So 1983 was my last year at Melbourne University, and so we had an open day and trying to think of what would be a compelling thing to show the punters in an open day in a controls lab, which is control theory is pretty esoteric, and so a lot of the simulation thing we had wouldn't be interesting to anybody. So I thought, well, let's build a drafts playing robot, and at that point you could buy a little hobby robot, maybe 4 joints, stepping motors. And anyway, we bought one and we connected it to a mini computer. This machine as big as a fridge, and wrote some code that would allow the computer to talk to the robot, make it move where it needed to move, and also had the rules of drafts in there. So I had a hasty recollection of this, but I'm pretty sure the person typed the move in that they wanted to make, the robot would move their piece, then it would figure its move and it would move its piece, and so it went. So that was, the rules of drafts weren't so interesting to me. I think I just copied that from a paper or a book, but connecting it to the robot and making the robot move, that was pretty cool. And that was the same time that my position at Melbourne Uni was coming to an end, and so I was interested in robotics. And then just magically there was this advertisement in the newspaper, CSIRO were looking for someone to do robotics, and they had a lab just down the road from Melbourne Uni, so it was very fortuitous. So I interviewed, I got the job, and went to work for CSIRO at the beginning of 1984. I got history with CSIRO through my dad, who used to work there, so so that was pretty cool. I think it's also an organisation that most Australians have heard of and most Australians hold in pretty high regard. So to be able to work there was absolutely a delight. And so my first day of work, I rock up there all wide-eyed, bushy-tailed, and the guy who was my boss said, He's leaving. He'd resigned and got another job somewhere else. So that was interesting. So he'd had the foresight to buy a lot of gear before he left. So this was a relatively new CSIRO division that had been created with a lab in Fitzroy in inner city Melbourne, and it was division of manufacturing technology. So early 80s, trying to do things to improve manufacturing industry in Australia. And Australia doesn't have a hugely strong manufacturing industry, but we do have a manufacturing industry, and it's quite a good adopter of technology. So this CSIRO division had been created to get CSIRO brainpower applied to the problems of manufacturing across the spectrum of manufacturing. And so this was a robotics group had been established in Fitzroy, and so the boss left and I was there with a lot of equipment, and we had a few other people came in at a senior level. And the first project that I worked on there was what's called, back in the day, a flexible manufacturing cell. You've got a bunch of machines, a few robots and conveyor belts and vision systems and stuff, and we wanted to configure them so it would do something useful to show people in industry who weren't using robots what robots could really do, because there weren't too many use cases in Australia at that point. And so it was to build a demonstration what they could do. So we wrote code for all the different robots and communication systems so they could talk with each other. And we had a German visitor at that time, Hartmut, and he kind of designed the overall concept, and I was put to work to design some of the robot code, and that was a great experience. And we ended up with a system. Your user could go up to it, and they could say what kind of little gearbox that they would want manufactured, and it would manufacture one of 4 different types of gearboxes. Type the gearbox you want, and the robots would go to work, and milling machines would cut metal, and parts would move along conveyor belts and be inspected, and gears would be inserted and meshed. It was pretty cool. So that was a kind of first big multi-person project I think I'd ever worked on. But in the same lab there was another group of people who were working on a vision system, computer vision system, and that wasn't really my project. But CSIRO in those days was pretty free form, and so you could if you go and talk to those people and hang out with them, and you could become part of their project too. So that was a wonderful freedom that existed in that lab at that time, and that's kudos to the people who led the lab at that time, that they gave us that kind of freedom. So the Vision System project was about how do you take an image from a camera and figure out what are the objects within the scene. Now we're going to say the scene's really simple. It's just a black background with white things in it, or a white background with black things in it. Yeah, and so you've got a picture like that, and you want to know how many objects are there, how big are they, what's their maximum, where's their center of gravity, which way are they oriented. And to do that in software, to take an image in with computers of the day and do that kind of processing would take seconds. And so one of the guys there, a guy called Miles Harding, very, very bright guy, metallurgist, but very interested in computers and algorithms, came up with a way you could do it in hardware. He kind of conceived, a custom chip, silicon chip, that would do this in real time. So as soon as the data is streaming out of the camera into the chip, it would be saying, okay, there's an object with an area of 40 pixels and it's here, and here's another object of size 80 pixels and it's located here. As the data was streaming in from the camera, information about the objects would be streaming out. And that's really important for a number of reasons. One is that the data that's in an image is very low density, right? It just tells you about how bright the pixels are. And that's generally not of interest. We're interested, when we look at a scene, we're interested in, where's the cup, where's the person, where's the chair. We need to lift it up the level of abstraction from pixels to objects. Objects are meaningful and you can reason about objects, and if you're a robot, you can pick objects up, like pick up the cup, hand the cup to the human, right? Drive through the room and not hit things. Yeah? So that's why you need to understand our objects. So this was a bit of a game changer, that we could do this processing. Sure, the world had to be all black and white, and there were some tricks we could do to make it all black and white, but to do this with all in hardware was pretty amazing. So I kind of bolted myself onto that project as well. And I got involved in silicon chip design and so on. We built a system, we licensed it to a company, which based in Adelaide. And so I spent a bit of time over in Adelaide working on this, doing more chip design and simulation and so on. And so I had a foot in two camps. Right? I had a foot in one camp which was looking at robotics, and foot in this camp, people looking at vision. So while I was doing that vision stuff, another person had come to CSIRO, a guy called Malcolm Good, and he had been at Melbourne Uni in mechanical engineering, and then he'd gone overseas on a sabbatical to the US to General Electric research labs, where he'd been doing a lot of work on robotics, and particularly how do you get a robot to have a sense of force perception. So there are lots of jobs that robots need to do where they need to understand the forces that they exert on the world. So for instance, if you want to put, classic problem, if I want to put a peg into a hole, right, you can do that with your eyes closed, because you can feel the interference forces as you push the peg in the hole. And if it's not in quite straight, the forces that you feel in your fingers will cause you to line it up straight and push it in. You can do that with your eyes closed. Robots can't really do that because they don't sense forces. They move things to a particular position. But if you use a robot that moves things just to a particular position, you're trying to do a peg in hole problem, insertion problem, peg will typically jam. It doesn't jam for humans because we sense the forces that the object is inflicting on the peg, and we adjust. Robots couldn't do that. So Malcolm had come back from the US, he'd been working on this problem at GE, and so we started working on that in the lab. So trying to equip a robot with the ability to sense forces that it was exerting on the world, and use those forces that were sensed to control, change, modify the motion of the robot. And the particular problem we looked at was called deburring. So in a lot of operations in manufacturing, particularly in casting, an object that's cast has got all this ragged edge on it. And a human grabs a deburring tool and they whiz it along and cut off the flashing, the rough edges. And that's a job that requires a sense of force. If you push too hard, you're going to gouge into the object, which is not helpful. If you go too lightly, you're going to leave some rough edges behind. So the idea, how humans have got that skill, and we know it's done by force sensation through their hands and their fingers, how can we imbue a robot with that same capability? So to do that, we needed to modify the robot so that it could take in this force information. So the robot, as you buy it from the factory, doesn't have the ability to do that. So that meant delving into the guts of the robot, the computer that controlled the robot actually, understanding how that software worked, reverse engineering that, modifying it, writing a whole bunch of my own software that would allow the robot to do what it needed to do. So I was inspired in doing this with some robot control software which had come from a lab in the United States, the University of Pennsylvania. So some of my code was inspired by that, but different to that. I thought it was more elegant, improved on the version that I'd received from that university. So I was working on controlling robots, and I was working on this high-speed vision stuff. I then was fortunate enough to win a fellowship from CSIRO that let me study overseas. So I spent a bit of time searching for a lab that would be willing to host me. At that point, I have only an undergraduate degree and a master's degree. I didn't have a PhD, and so getting into a robotics lab was not overseas, was not as easy as I'd expected it to be. Anyway, I wrote to a professor named Richard Paul, who's known as Lou Paul, at the University of Pennsylvania. So he's the group that had provided the software that I had modified, improved to use at CSIRO. And I wrote to him, and he just wrote me back this email and just said, "We'd be delighted to have you." So that was wonderful. So 1988, set off for University of Pennsylvania, which is in Philadelphia, with my wife and 9-month-old baby.